Hi everyone, how was your weekend? Yes, actually now there is almost no difference between weekdays and weekends. We have to stay at home. My soccer team decided to stop playing soccer for a while. It seems New York is implementing the most strict rules and enforcement. I hope it will work and delay the spreading virus. Okay, last time we started talking about data analytics and look at history, application examples, and types of business analytics. We also look at data visualization as one type of descriptive analytics, right? Today, we can start from predictive analytics. With predictive analytics, we ask not only what happened in the past, but also what's going to happen in the future, and how it will affect us. There are some examples of predictive analytics you can see. We are going to talk about it in detail shortly. Data mining. Firstly, what is mining? Mining is extraction of valuable minerals or other geological materials from the earth, right? You can apply it to guess what data mining means. Data mining is the process of discovering useful patterns and trends in large data sets. Data mining find or discover hidden relationship patterns from data, and it can be used to explain observed events or condition or confirm hypotheses or analyze data for new or unexpected relationship. Then what is text mining? Text mining draws patterns from unstructured data, specifically textual data such as emails, blogs, and other textual documents. Today, the internet contains a wealth of valuable information, such as customer product reviews, that is typically unstructured and difficult to analyze. The process of gathering and processing these unstructured data is called text mining, and companies that are effective at performing it can assess customer sentiment and increase customer satisfaction. Web content mining uses clickstream data and web crawler. And here you can see diverse data mining techniques. I'm not sure whether it is necessary for you to learn about this now, but just for your knowledge, I will briefly explain some of these, okay? The first one is regression. Regression analysis is the method of using observation, which are data records, to quantify the relationship between a target variable, a field in the record set, also referred to as a dependent variable, and a set of independent variables. As an example, let's take a sales numbers for umbrella for the last 24 months and find out the average monthly rainfall for the same period. Plot this information on a chart, and the regression line will demonstrate the relationship between the independent variable, rainfall, and dependent variable, umbrella sales. And you might guess that in the future, there is a connection between how much money your firm invests in R&D and how much you earn from it. Regression analysis can help you quantify that. Regression analysis will provide you with an equation for a graph so that you can make predictions about your data. The next one is data decision tree. Decision tree is a graph that uses a branching method to illustrate every possible outcome of a decision. It breaks down a data set into smaller and smaller subset, while at the same time an associate decision tree is incrementally developed. It uses if and then rule as represented in the figure. Informally, decision trees are useful for focusing decision when a group must make a decision. And programmatically, they can be used to assign monetary or time or other values to possible outcome so that decision can be automated. I prepare a case to help you understanding. Let's picture that you are thinking of going to playing golf, and you have some consideration to make the decision, such as outlook, temperature, humidity, wind. The final result, um, and then based on the predictor, and then you can make you can draw the decision tree model, and then you can see the outcome. The next one is clustering. Clustering is the task of dividing the population or data points into a number of groups based on various feature and attributes. Thus, the data point in the same groups are more similar based on these features. Other data points in the same group than those in other groups. In simple words, the aim is to segregate groups with similar traits and assign them into clusters. There are a number of opportunities, numerous opportunities for using data mining techniques in the real world. The first application example is using clustering or classification. You can develop profiles of uh, high value customers versus low value customer, and you can do target marketing by implementing different business or marketing strategy for each group, and you can identify possible credit risks of customers based on their purchasing behavior with their credit card. And using the regression, you can test the relationship between a certain marketing campaign and your firm performance. And using a decision tree or clustering again, you can see which groups of customers are more likely to leave for competitors or stay within your services or product. The last and the most advanced analytics is prescriptive analytics. Prescriptive analytics takes the output from machine learning and deep learning to predict future events and also to initiate proactive decisions outside the bounds of human interaction. Simply, with prescriptive analytics, we ask what the best decision to make is. An example of prescriptive analytics in our life, in our real life, is an autonomous car which transports you safely to a destination that you determine. It selects a route based on the analysis of current data regarding traffic, congestion, or route optimization. While driving, it will still collect data on the road in real time and make the best driving decisions based on the prescriptive analytics. This could be simple as to your doctor based on external input such as personal device-based heart rate monitor, social media input, proximity tracking that recognize that you have been exposed to a flu virus and will require medical care. And next one is about machine learning. What is machine learning? Can you guess? Machine learning is making computers learn from the data and predict future outcomes. Can you understand? Can you get it? After learning from data, the machine can analyze new data in the real time and predict future outcome. It will help a decision maker to make a well-informed decision. Learning from data without being explicitly given instructions machine to do so. And how is machine learning different from artificial intelligence? And we can include maybe deep learning too, right? Is there anyone who can clearly differentiate artificial intelligence versus machine learning versus deep learning? I want to ask this question in the classroom, but I can't. Although the three terminologies are usually used interchangeably, they do not quite refer to same things. Firstly, artificial intelligence is the basis for mimicking human intelligence processes through the creation and application of algorithms built in a dynamic computing environment. Application of artificial intelligence, shortened to AI, can be seen in everyday scenarios like financial services, such as fraud detection, retailer purchase prediction, and online customer support interaction. Um, uh, deep learning. Deep learning is a subset of machine learning. In fact, it's simply a technique for realizing machine learning. Actually, we don't need to distinguish these things. Terminology doesn't matter much. I'm not going to ask you to tell this concept correctly. Just remember the core concept in data analytics. To answer your business questions, you have to know firstly, what is the data sources available or needed, right? And after collecting and processing data, you will use proper data analytics or statistical techniques such as regression, clustering, text analytics, decision trees, or other based on your purpose, okay? And then language, programming language. Nowadays, to handle big data, these programming languages are the most popular: R, Python, and Apache Spark. If you want to become a data scientist or get a job related to this area, you have to be good at using at least one of these languages. These programming languages have many advantages over using traditional programming languages such as C, C++, Java, this kind of thing. Key requirements are speed, availability, and access. Big data analytics have already significantly affected these areas of human activity, right? Do you agree that? There is potential for a much more significant transformation in these and other areas as time goes on. Success in these areas requires significant effort in the collection, organizing, quality control, and analysis. Big data analytics also raise a number of important questions regarding possible negative implication. For example, personal privacy versus collective benefit, ownership of data and access. Do you remember that It is the issue of using cloud computing and demands for workforce capability and education. I think it is the reason why computer science and information system majors are popular for both students and company these days, right? Okay, we stop here and we'll be talking about the database in the next lecture. Okay, have a good day and stay healthy. Bye.